Hi, the section 3G. So I discussed how to deal with the A right angle 2n, A right angle 3n, and so on. So this is a kind of the technical section that to relate the A right angle 2n and 3n to A right angle n. So for example, 10-year annuity and the 20-year annuity and 30-year annuity, those have some relationship described by the interest rate I. Okay, so we do two examples. And the first example, suppose that A right angle n is equal to 8. So n is probably more than 8 years if interest rate is positive. And A right angle 2n is equal to 15. Then we would like to determine I. So it looks complicated question, but actually if we use the relationship between this and this, that we can easily solve this for I. Okay, so think about the A right angle n and A right angle 2n. We have time 0 to time n plus 1 up to 2n. Then the A right angle n. Okay, so at first A right angle 2n, A right angle 2n. This is the cash flow of $1 each for 2n years. So 1, 1, 1, 1, 1 up to 1. And how about an? A right angle n is $1 for n years. So the difference is this another payment of n years, but starting at n plus 1. And okay, so we have the 3 cash flow, maybe the 1 and 2, and the first one is A right angle 2n. Okay. And actually, this first payment present value is A right angle n, but the second payment is also described by using A right angle n because this is n payments of $1. So to be exact, the present value of 1, okay, so present value 1 is A right angle n, but present value of number 2 is actually n years deferred annuity. So this is the v to the nth power times A right angle n. So yeah, so for example, the calculate the value. Consider the value at t is equal to n first. Then multiply v to the nth power to go back n years. So this 1, 1, 1, 1, 1. So this payment is worth A right angle n at time n. So we go back to n years, go back n years to 0. So present value is v to the nth power A right angle n. So this is the same as the A right angle 2n. A right angle 2n is equal to A right angle n plus v to the nth power A right angle n. And our assumption is A right angle n is $8 and A right angle 2n is $15. So that means 15 is 1 plus v to the nth power times 8. So that is 1 plus vn is 15 over 8. Vn is 15 over 8 minus 1. So this is 7 over 8. So now that we can determine I, because the V right angle and yeah. So maybe one more trick. So at first, at least we get this one. Then we can plug in this to the original equation. So A right angle N is equal to 8. So this means A right angle N is 1 minus V to the nth power. So this over I is equal to 8. So plug in. V to the nth power is equal to 7/8. Then 1 minus 7 over 8 over I is equal to 8. So that means 1/8 over I is equal to 8. So multiply 8 on both sides. Then take the reciprocal. Then I is equal to 64 over 1. Right, so 1 over 8, and we multiply by 8, and I is equal to 1 over 64. So this is 0.0156, so 1.56%. So in this way, even we don't know N, but we can calculate interest rate I. So just to repeat the important part, A right angle 2n, this is always equal to 1 plus the V to the nth power times A right angle n, because the $1 payment for 2n years is separated into 2 payments of 2n payments of $1. Then each of them are represented by A right angle n. And I would like to add one remark on this example. Although we have already solved I is equal to 1.56%, actually, if we solved for n is not an integer. So we assumed that n is an integer. Actually, the problem assumes that n is integer. But actually, if we solved this, then we get n is between 8 and 9. So this problem is ill-posed, even though we can solve this for I. So this is not really a good question.